Started. So hi everyone, I'm Niam, I'm the Director of Engineering at Coursera. So I was part of Coursera at the beginning of it. And for those of you who are not familiar with Coursera, we are an education and technology company working with the top universities in the world to try to provide, get towards an idea of universal access to education in the world. So a lot of what we do is thinking about how technology can impact education to help make it scale, to help access and give the broad audience in the world who don't have access to the higher education a great learning experience and a great increase opportunities in what they could do in their lives. So as part of that, we do things like thinking about how learning could happen online. We do things like how teaching could happen online, and thinking about all those problems that we're trying to get to. So as part of that, a lot of technologies that we develop on, we do things like service-oriented architectures on Scala, visualizers on Play, and so on. And a big part of it is figuring out how we can process large amounts of data in our classes. And part of that is like thinking about how, for example, given all our students' grades and all our student information, how can we process that to draw meaningful information from it? So Mesos is one of the technologies that we've been using internally. And today I'm very happy to have Ken here to tell us a bit more about how Mesos works. And also later Colleen to tell a bit more about how Coursera uses Mesos and Docker in our internal tools and internal services. So just a bit about Ken. So Ken here, bring intro on you. So Ken's a cloud solutions architect at Mesosphere, and he's focused on helping companies simplify the development and operations of large-scale infrastructure. And so before Mesosphere, he was leading the research and development team at the CloudLink Cloud Business Unit, focuses on cloud and data center automation. So he's an author and award-winning speaker on practices of software engineering, agile development, and all of that. So very happy to have Ken here talk to us about the future of development on the cloud. And going to go ahead. Please give a hand for Ken. Okay.
It's dangerous to mic me up. You guys can hear me okay, or no? Because I like to walk around. You guys can hear it in the back? Yeah? All right. So I'll just do that. I have like a lot to present, at least prepared to present, in a short amount of time. So I'll probably, if I pass a slide really quick, like, hey, wait a minute, that's because I probably don't have time for that. It's like a 90-minute talk that we're going to do in 45 minutes or something like that. I think we started early, so that's a good thing. I'll answer whatever questions you have. We can talk roadmap stuff if you like. It's really interesting to give a talk in Silicon Valley. I can tell you that for my career, I'm from the Midwest. I don't know if you recognize the accent or not. And I've made a career out of learning what the cool kids are doing on the West Coast, becoming an expert at that, and 3 or 4 years later it becomes very real for me. It makes me money in the Midwest, so it's really bizarre. I started with Mesosphere just a few months ago, and I don't have that advantage anymore. I'm constantly working with some of the smartest people that I've ever worked with. So it's kind of cool. So I created this talk, the future of cloud development, or the future of development actually. And I 100% believe this. I started last year as the head of research and development at Satis, which is part of CenturyLink. It's the 3rd largest telco in the world, is my understanding. I was asked with 4 people in St. Louis, which is where I'm from, combine that with 2 people in Santa Clara, we were supposed to come up with where's the cloud going to be 2 to 5 years from now, which is quite comical because we as humans are absolutely terrible at this. And if you combine that with technology, it's like even worse, right? There's some great books out there on how we're just terrible at forecasting, and frankly, we're really bad at even memory. Some great books of recent that I really enjoyed is Mistakes Were Made, But Not By Me. So if you get a chance, you should read that. It's really great stuff. But we quickly hone in on 2 technologies, and I'll just shortchange the conversation because you probably already know I'm going to talk about Mesos. The 2 things that stood out to us were Docker and Mesos. Docker at the time was 0.3. So we're looking at, and we're trying to convince people that, hey, this thing that's 0.3 is going to be incredibly important. And at that time, the first commit was in January of that year, of last year, right? It's pretty amazing where that has gone. And it's really not about Docker, it's about containers. But Docker made it approachable to other people. How many people are familiar with Docker already? Okay, quite a few. Okay, good. How many are familiar with Mesos? Because I already see. Oh, wow. Okay. This will be interesting then. See if you have the same flavor as I do on the same take on this. So we'll get started. I am a solution architect at Mesos. If you want, I've created a USB, which I don't think I have enough with me, but we've open sourced that essentially. I could point you to it. There's a place online. So the question I have for you now is this. When's the last time you saw the fail whale? Now a lot of people will attribute that to a transition that Twitter made from Ruby and Ruby on Rails, and oftentimes called the monorail, onto using a language on the Java platform. All right, so that's usually what's attributed to it. It's really fascinating because the conversation at the time, several years ago, was that it's incredible. It's almost impossible to create a scalable application with a dynamic language. You had to rebuild the type system. I remember laughing at this. It was pretty silly. Because I don't really think that's a scaling issue, and frankly, if you're building a type system in a dynamic language, you're probably doing it wrong. But at the same time they made the language transition, they also made an infrastructural transition to Mesos. And so we'll talk a lot about that. All right? So to start this conversation, I want to talk a little bit about legacy. And that's a really challenging word. Right? It's very subjective. But I'm going to give it a definition, and we'll give it a shot and see what you guys think about it. And we'll talk about some trends in the data center. There's definitely some drivers that are pushing us in a certain direction. We'll talk about some goals, and then I'll show off some Mesosphere stuff. Hopefully get to some demos. So in the data center, there's a perfect storm. What does that storm consist of? Well, a number of things. The first of all is talk about this legacy data center. What do we do in the data center? Well, we statically partition things. And when we say statically partition, what we mean is we take a number of hardware devices, and we create a number of virtual machines on each one of those devices, and we say, you know what, I need a Hadoop cluster. So I will take 9 of these things and carve that out, and we'll call them Hadoop 0 through Hadoop 8, or Hadoop 1 through 9, whatever you want to call them, but you give them a static partition in your data center. This, by the way, defines for me what I consider to be a legacy data center. If you require the knowledge and location of a given resource or service on a specific IP address and port, then you are running a legacy data center. Right? So that's pretty far-fetched because most people are there. That's where most people are. But if you want to scale, you actually need more than that. So the next step here, of course, is within the cluster, we need some place to run Rails or Java Tomcat or some kind of web service. Cool kids, I'm sure, are using Node because it's fun and new, right? And then we want to adjust our Hadoop cluster. So we need to make some adjustments. So humans get involved. They're like, well, we need more of these things. And so they take out their chef or their puppet, they point it at a few more nodes, and they start spinning off new instances. Right? That's the model that we're used to seeing. The problem that we have is that humans are involved. You could claim you could automate that because we have automated tools. Frankly, whenever I have an admin or ops person working with Puppet or Chef, they claim that they have to test the result of that thing. In fact, I was just talking with a client today, or a potential client, frankly, and their problem was this. They had Chef, they would point it in dev, they have everything working, they were building out some Mongo instances, and when they were pointing their Chef recipes in their production environment, it was actually using different repos, so they were getting different results. And so now we have a problem where I expect predictability, and I don't have it. All right, and this is a common problem. So you have 2 different models that we tend to work with when we start talking about virtual machines. The first model is that I call them cookie cutters. We create Ansible, Salt, Puppet, Chef. We have some kind of recipe that generates these things. And we've already given some sad stories around that. The other model I refer to as the Netflix model. The Netflix model essentially is they test an instance of a VM, and once they know it works, that's the thing, right? They don't have a cookie cutter recipe for it. That's the thing. If they want more of them, they'll instantiate multiple instances of that thing. And that has a different problem that we want to talk about. Let's stick with the statically partition. What's the other challenge? I have a known IP address and a port. Now, what's the alternative? What if you didn't know what IP address this was going to land in? Or worse, what if I didn't know what port it was going to land on? How would you administrate this thing? And that's the first question you tend to get to, is that we have ops teams or admins who are kind of like wondering, how do I manage this thing? And frankly, we're a little bit immature currently, but I'll show you some tools in a second. It's a lot like asking this question when you're statically partitioned. I want to start up an instance of IE, and the first prompt you get is, which CPU would you like to run that on? Right? If we were building applications for our laptops like we do for the data center, this is what it would look like. And the question is why can't it be as easy in the data center? And our focus is to do that. The focus of Mesos is to do that. Is to make the data center look like it's one instance of a thing, right? An aggregate of services. So, the second challenge that we have is resource utilization. Because as soon as you statically partition, your problem looks a little bit different. All of a sudden, I have something that's dedicated to Hadoop. And when it's not doing Hadoop, it's not doing anything. And when it starts to scale up and I'm absorbing a bunch of the load of the web, I can see spikes, but I still have some utility. One of my favorite talks recently, as I was at Mesoscon in Chicago, this was last month, I believe. John Wilkes is there, and he's kind of considered to be the godfather at Google Cloud. They were showing some pretty interesting graphs, and in the graphs they would have different colored lines, but across the top would be these white lines of varying sizes. And essentially the white lines were the capacity that was not utilized on that particular node. And his phrase was, white is evil. At Google, their entire focus is to absorb all of the resources of a given node. And for us, we can just do better. Like just the enterprise, a corporate enterprise can do better than what they're currently doing. So we're not trying to maximize everything, but we can certainly do a lot better. So that's the focus of where we're going with Mesos. In fact, I'll give you an interesting story along these lines. I wasn't a part of the company at the time, but Mesosphere put, or helped put HubSpot, completely EC2. It's on Amazon. They switched them over to using Mesosphere, or Mesos. And the end result, they went there specifically for administration. They wanted one administrative console. It was essentially to reduce overhead and pain within their ops team. What they realized instead was a 50% reduction in their Amazon bill. And the reason why is because of this. We could take resources and bin pack them on the same node. It was freeing up certain nodes to be completely idle. They're not paying for them, but yet we have the fault tolerance to fall over to those idle nodes. So it's an interesting thing that they gained out of it, essentially by surprise, a 50% reduction in their bill. Now, if I'm anywhere else, I end up having to explain this a little bit, but there is something that's been around for some time. It's the Google board. The Google board essentially has been around since about 2008. Google has the most experience, as far as I know, of any other company on the planet at using containers. They've been doing it for a very long time. The thing that's fascinating about Docker is that we're all intrigued, right? That this is a huge change, and the reality is it finally made it approachable to the general corporate environments, right? For the general public, essentially. But Google's been doing this for a very long time. In fact, there's a great article, you can see the link down here. There's a great article on how Mesosphere is bringing the Google board to the enterprise, to the corporate enterprise. So that's our focus, is trying to do that. We can talk a little bit more about what that is. Their latest rendition of the board really is called Omega. It's been 3 years in development and still not in production. So it's interesting to see where they're going to go with that. So another problem we have is time to production. Florian is our CEO at Mesosphere. He is the person who wrote user search and Twitter. He completed his activities. He was completely done with the feature, and it took 10 weeks to get into production. And as a developer, I'm sure you know what that feels like, where you're ready for this thing to be used. You want to understand any kind of feature request beyond what you've already done, and you're stuck. Why? Well, you got to hand that over to your ops team, and they've got to create a chef recipe, and they've got to create a staging environment. And of course, they don't want to do that for just one feature. They're going to combine that with 2 or 3 other features, and well, it just takes time. And so, one of the things that you'll see at Twitter is this move where we have a cluster that includes staging and production. It's a different thing, right? The other challenge, the other advantage you have when you're using that container technology, which they're not using at Twitter. They're not using Docker anyways at Twitter. The other advantage you have is once you have something functional, it's functional. You don't have, it works in all environments the same exact way. So this time to market is, again, this is that perfect storm we're talking about. There's this move, these words that we tend to see quite a bit now of DevOps, trying to provide engineering discipline and operations, as well as continuous delivery, which falls out of the Agile space. So these two terms are quite popular, been around for a few years, but we're still, if we have a weakness when it comes to continuous delivery, I refer to it as the last mile. We're pretty good at getting things to CI, to continuous integration. Beyond CI, it's kind of hit and miss as to what people do, but the last mile is terrible for most organizations, trying to get it past that next step. So virtual machines, what's our challenge? I talked a little bit about this. When you get to virtual machines, here's what my research concludes. About 30%, and it varies, but about 30% of your node's utilization is consumed by the virtual machine itself. So between the hypervisor and what's needed for the virtual machine, it's consuming a large amount of resources. It's just not necessary. I can't talk about the company. I'm not allowed to. But you know who they are. They're one of the largest tech companies in the world. They just took a cluster and removed all their virtual machine licenses. They have no virtual machines at all. They went bare metal. So they removed millions of dollars of licensing fees that they were paying VMware. At the same time, they gained, for them, they gained greater than 40% utility out of their existing data center. So not only did they remove millions of dollars, but they gained 40% of the data center. And they're extremely happy with the end results, and they are looking to move the rest of their clusters in this direction. So it'll be interesting to see. That'll be a big name if we can get them to claim that we're involved. We'll see where that goes. So virtual machines. The other problem you have with the virtual machine is it doesn't tell you jack. An admin does his job, his or her job, goes in and fixes something because they were firefighting and needed to do it. What changed? You don't know. It doesn't tell you. It doesn't have any information. It's just lost. Unless you write it down, put it on a wiki somewhere, it's lost. Right? So there's very little information you get out of a virtual machine. The other problem you have, as I mentioned, you have two different models. You have the puppet and chef model, or essentially creating recipes. In that model, you get varying successes depending on repositories you're pointing to. In the other model, the Netflix model, if you have a 1 byte change because you missed a configuration, you get a new 2 GB image. So the two models you have are those two different models, and they each have their own challenges as far as management goes. But it's all about metadata and the heaviness of the solution, how long it takes to reprovision something. The additional information here, of course, is that a virtual machine takes on the order of seconds, usually tens of seconds to start up, where a container is milliseconds. So when we talk about heaviness, it's somewhat subjective, but I think we all know that it's better. So there's some additional summarization of the things we just talked about. So we had this perfect storm. The second thing that we want to talk about is this trend in the data center. So the first trend we see in the data center is where we used to put a number of applications on a given virtual machine and then have multiples of those on a given bare metal machine. We actually see a flip. Now we have applications that are using aggregates of the data center, aggregates of machines. So this would be inclusive of like a Hadoop cluster or Cassandra, or you can go through a number of scenarios, but we have apps now that are not just on one machine, they're across machines and they're using aggregation. So there's definitely a direction of a number of apps moving, I can't speak anymore, but we have a number of apps that are moving that direction. So from client-server era to more of a cloud era. So when we talk about aggregation, we talk about CPU, we talk about memory. That's the one that we're most familiar with because we start talking C groups within the Linux infrastructure. Those are things we tend to know quite a bit about. We have a number of companies pushing this in a given direction. Groupon is looking to use Mesos, and one of the drivers that they've been trying to influence us on quite a bit is actually the control of I/O. So it's really fascinating. Within the next, I'd say within the next few weeks, every time I say that it's a little bit longer, so double that. In the next 6 weeks, I would say that you would see the ability to constrain I/O. What we have on a branch essentially is egress, where I can say when I launch off an app, you get 1 gigabyte of this 100 gigabyte band on outbound. So we have outbound, which is egress, right? We don't have the control on the flip side. So you're going to start to see constraints in this way, which gives us control over the data center. But this aggregation is a very important aspect of where we see things going. And it gives us true elasticity. This is another important aspect of where we're going. And then we have Docker. I'm not sure how much I'm going to spend on Docker at this point, since it seemed like a lion's share of people are familiar with it. Docker adds to the container world a couple of really cool things. Because containers have been around for a while, as I mentioned. 2008 is about when Linux containers, or LXCs, came out. Of course, they're all really based on C groups and namespaces, which have been longer than that, and you go back to True, things like that. What Docker added was, the biggest thing they added, which was super cool, was image, the way to lay down a file. Right? So they created a standard around that, super great stuff. And the cool part is, a 1 byte change is a 1 byte change, or close to it. So the management of the delta is there. The other thing that you get with Docker, and I've assumed you've tried this before, is if I make a change to a Docker container, I can ask it what its diff is. And it actually knows what the delta is. So I can ask it questions. I can get data from it. I can understand what happened. The other aspect of this is that we were referring to this within our research group as immutable containers, and they are. It's an amazing thing that I have a SHA that represents something that I can always go back to. It's always the same thing, period. It's much like a Git SHA. You can make the analogy at least. It's not exact. So there's the diagram. I don't necessarily like Docker sitting on top of it, because Docker is really the management of those things. That's the second thing they added. It was really challenging to have an LXC that you are managing all on your own, managing the connectivity of the NIC, whether you're a host or a bridge mode, as far as networking goes, management of the connection of the standard in and standard out. All of that's handled for you in a very simple way. So the thing is if you've ever run Docker, it's not terribly impressive, but that's the point. The point is, it does some magical things for you where you don't have to think about it anymore. There are some additional challenges there, though, in that Docker, the company, is pushing things in a direction that I don't think makes sense from a clustering standpoint. Because Docker actually makes a whole lot of sense when you look at it on your laptop, right? And some of the technologies they're coming with, like linking containers, totally makes sense when you're a single instance model. As soon as you spin out to a multi-instance model, and as soon as you spin out to a cluster, that doesn't make sense anymore. And so I'm a little shocked in the direction they're going. We'll see what happens. They're also spinning up an orchestration umbrella, if you want to call it that, called LibSwarm. And LibSwarm is just talk. It's just a bunch of people trying to create orchestration under the guidance and umbrella of Docker. Nothing truly exists there. Nothing's in production for sure. In fact, there's very little there. What else? Yeah. So LXCs, again, been around for a long time. It's the same thing we were using with Heroku. Heroku is, their dynos essentially are LXCs. So from a developer perspective, here's the cool stuff. This is what I would need to do in order to spin up an instance of a Docker repository. This is what I do today. So what's going to be really sweet as a developer is you tell a developer, hey, I need you to start up an instance of CouchDB. And this is the solution. You just do a pull and run. There's no more complexity anymore. I just was speaking at Java 1. I've been a Java developer for some time. Sorry, I apologize for those who are not forgive me, I was young and hated money. But there's an interesting thing in the Java ecosystem. There's a thing called Nexus or Artifactory. They're component repositories, and essentially I create a jar, and I push a jar into this repository. And it gives me a lot of metadata, and it's really cool. Because the metadata tells me the dependencies of that thing. And it even has transitive dependencies, so I can follow it all the way down to, it's turtles all the way down to know it, right? The other thing we do, though, is we take a WAR file, and we put that into a Nexus repository. And that makes no sense whatsoever. Like, we do it all the time, but it makes no sense. It's not even the same audience. The person who's going to use a WAR file is not the same person that uses a jar. The person that needs the WAR file is someone who's going to be deploying a thing, not building a thing. But the other problem that you have is the war file without any additional metadata is useless to me. The other things that I need to know is what roles does it use, and how do I change the server.xml config file in order to make that thing work. So it's like the nucleus or the embryo of a service, but I need more data. I need something to make it work, and so that's what Docker is. Docker is going to be this ability to spin something up, stuff a war file in it, and it just runs. There's nothing else to do to the thing. Then it's going to be your decision as an ops person to decide, okay, I've got this port, where do I want to home that behind? I obviously want to have that as a back-ended port for an H8 proxy or some kind of load balancer. Right. So there's some really cool, beautiful things that are coming out of this container space. They are truly immutable containers. I won't go into more detail. I have more thoughts on that, but I don't know if it's going to be worth a conversation. So stop me if you want to have a conversation. Here's the first question that any developer has if they've used Docker and they go, this is frickin' awesome, because it happens all the time. But the next question is, how do I scale this into production? And you can see that there's like 6 answers, but the reality is that first answer is really, really long. The first answer is going to have things like Shipyard and Fleet and CoreOS and Mesos, and it's just going to go on and on and on of the ways you can go into production, and not one of those do I know is in production. Maybe not true. What's that?
What about Kubernetes?
Yeah, that's a slide coming up. We'll talk about Kubernetes. It's not real yet either, right? It's a cool, but all right. Stop me. Go ahead.
They're all kind of real because people are playing with them, but I don't think any of these are in production.
Yeah. No, nothing's in production. I do know that we have Mesos. We do have Mesos with Docker in production for a specific client. So someone would help put it there. See, people are going to challenge me, which is fun. I might learn something tonight. It'll be good. The problem is that everybody's got this question, and yeah, we'll see. There's a race. There's a race right now. There's a race to figure out how to solve that. Here's the cool part from a Mesos standpoint. We are battle tested in production at Twitter with tens of thousands of nodes on. I can't tell you the exact numbers, but reaching on the magnitude of 6 digits of nodes as opposed to 5. So it's a big, big deal. Like, I don't know clusters this size, and we have them. It's real. So the only other challenge is how well did we integrate Docker to make Docker do that, as opposed to just what we have for standard Mesos containers today, which is using Cgroups. POSIX if you're on your Mac, so you can actually run Mesos on your Mac if you want to. So, great question. Kubernetes. So, once again, I don't know of any other organization on the planet that has more experience with containers than Google. And we could learn something from them. Now, probably have some Googlers in the room. I'm scared to talk. When this first came out, was first announced, it was announced at DockerCon, which was in June, in the second week of June. The challenge that you have with it was there was some hoopla surrounding it, some marketing challenges, and the challenge was, hey, they're releasing the Google board to the public. No, that didn't happen. There's nobody on the Google board team or on the Omega team that is on the Kubernetes team. It's a different team. It's a different problem. But they are taking advantage of their knowledge, which is super cool. And one of the things that we've learned as we've talked with and worked with the Googlers is that whenever they launch a container, they almost always launch another container with it. There's a sidecar container. There's another product out there trying to create POS solutions for the enterprise. It's called Gaius. They are going to be using Mesos, as far as I know, as the scheduler. We've had them in for Hack Week, and they're trying to transition to using Mesos. They have a deep need to also run sidecar containers, so a second container that's nearby. Right? Now, what I see a lot of developers looking at is, hey, maybe I want 2 containers that talk to each other a lot in the same pod. The term that the Googlers call it in Kubernetes is a pod. And that's not what they use this for. I don't know if there's a place for that. Maybe there is. But the way they tend to use a pod is you have a primary service, and you have supportive services around that primary service. Things like having the same mount point between these 2 containers and spinning off of logs or looking at analytics, or you can go through the list of things, but it's not another primary service or a dependent service. It's intended to be, as far as they use it and as far as I know, kind of a supportive service. Now within a pod, it's all, everything has NATed, so you have one IP address for a given pod. So that's one thing they've added, is this concept of a pod. The second is tagging, which I won't go into huge detail to, but it makes a whole lot of sense. It's obvious almost, right? You can tag a pod as being front end or back end, and it's arbitrary. You can give it any name you want, so then you can have control over it with some kind of naming convention, which is sweet. The last thing that they've added is something that's near and dear to my heart because it's a pain point, but it's service discovery. Now the way they do it will work well for many. I don't know if it will work for all. That's where you get into problems. I think they give a slant 24 to a node, and as long as you can tolerate that, that works great. As soon as you can't, then you've got a challenge, right? But everybody's having the same problem. Service discovery is a pain in the tail. It's just a real pain in the tail. Your options, do you want to step through real quick? Because I don't have a slide for this. But service discovery, let me mention this first. When I talk about service discovery, the idea of a service finding another service is not the only problem, right? That's easy. That part is super simple. The challenge you have in a distributed cluster is that if service B, the dependent service, fails and starts up in another place, what happens with the primary service? How does it rediscover? Or how does it maintain connectivity? Right? And the other challenge you have is the whole internet's freaking broken. It's broken. You have Java that does a DNS resolution and never makes a call again. It sticks. It has a cache that it never refreshes. We have a bunch of different things that are broken on the net that we're trying to make work within this model. So the problem you have is this: do you want to create an environment where existing services can be spun up into a cluster and they work, or do you want to rewrite things or create watchdogs for things in order to make them work? Those are the models and problems that you have. So we actually have a really cool project within Mesosphere. It is open source, called ServiceNet. Super cool. We were essentially making adjustments of IP tables underneath the covers. If a dependent service went down and was restarted, we would essentially have an elastic IP. Your connectivity to the existing IP just moves somewhere else. It's really, really cool with some aliases and IP tables. You can do some magical things. It was tested to a certain level of scale. I don't know how high that would go. We had some great tests, but here's the problem with it. It only works in an IPv6 world. Nobody runs IPv6. I know of one group that said they could. Like if we absolutely needed you to, we could move it to v6. And we could do it through a v4 tunnel, but the v4 tunnel caused like a 30% overhead that we thought was not tolerable. So we stopped working on that project. Yeah?
I think one of the things that I haven't heard you mention regarding Kubernetes is that as a user, so like us,
yeah.
The nice thing is that you can actually move your containers to different clouds. Like it runs on Google Compute, runs on Mesos,
yep.
Runs on CoreOS, runs on VirtualBox. So it makes it very easy to make the providers replaceable.
Yeah. So that's super cool as well. Well, you know what? So here's my understanding: is I know that that's the goal. I don't know how real that is. So do you have experience with that, knowing that that is real?
Well, I mean, it runs pretty well in Google.
Yeah.
I've tried on my VirtualBox. Certainly a new project, but the good thing is if you look at Mesosphere supporting it,
yeah.
Google is supporting it, Amazon is supporting it, and people are constantly adding more of these platforms. So I have no reason to believe that it doesn't work.
Yeah. No, that's awesome. And so you can see it up there. We have the Kubernetes Mesos project, which is to put that concept within Mesosphere, right, or Mesos.
Yep.
And the whole goal would be make it portable, right? I don't think Google's taken this anywhere outside of their infrastructure or their cloud, right? So if you want to bring it on board inside your data center, you're going to have another solution that supports it. But I can tell you my exposure, what's that?
What do you mean? Can you explain it a little more?
I just mean that like if Deis supports Kubernetes or Mesos supports Kubernetes, then you could take your pods and such and port them over to your own data center, but Google's not going to be supporting other people's data centers. As far as I know.
I mean, obviously you have to run Docker containers, so you just advocate Docker, to be an easy way to transport these things. So getting it out of Google is trivial.
Yeah. No, I'm with you. I'm with you 100%. So here's my only pain point that I see is this, and it sounds like you guys have some, either you're on the team or you have some deep exposure. The thing is that we have some huge pain points with the amount of thrashing that's happening on the API layer. So we have regular, everyday changes that are happening. At some point, our team just said, okay, and kind of just left it stagnant. Fortunately, somebody in our community, in the Mesos community, stepped in and decided that they were going to bring us back up to date. But there's still a lot of changes. I don't know the right term. I'm not trying to be derogatory. I just know that there's a pain point for us to try to keep up. So, yeah. But with that said, I do think this is the future. The future is what we're seeing here, and it's a big deal. And in fact, it is probably one of the best things that Google's come out with. And the reason why I say that is, it's hard to see Amazon losing its grip of the IaaS, dominance. But I think this is exactly the point in time where it could happen. Like with containers, like I don't know if it'll happen. I'm not even saying it'll happen. I'm not forecasting. I'm saying it's this kind of disruptive technology that gives someone else the ability to take that over. That's what
It really does commoditize the infrastructure.
Yeah.
So at that point, Amazon has to compete with prices of
Yeah.
that's all they provide.
And so now, yeah. So the economy, yeah. I'm with you 100%. It's going to be interesting. We're so in the infancy right now, right? It's like I don't know. Like I said, I'm from the Midwest, so I go back and I sound like a freaking alien to everybody I talk to. They're like, "What are you talking about?" It's like, no, you don't get it. It's all going to change.
So one of the conferences, Google said containers and VMs, equal partner, they have coexist or something like that. He said VMs provide better security, containers don't. We have to come from that.
Yeah, I just recently had a conversation around that. So again, I see a lot of people moving away from VMs to get rid of the license and to increase their utility. But you're absolutely right. There's still challenges within the container space around security. So far as I know, you can still break out and get, especially in the Mesos world, and I'll show you the exact places I'm talking about. But you can jump from one sandbox to the other if you so desire. But even, yeah, so there's lots of challenges around that. And so if security is your main concern and multi-tenancy is your concern, you may still need to be on a VM to manage that. I would love to see where that's not the case, because there's a lot of overhead associated with that as a consequence. But yeah.
Just a quick question on your comment on the swarm being all talk.
I don't mean all time. I'm probably too. Like
I'm
someone's
not
already
telling you,
like
I'm not telling you.
gonna beat me up in the hall or something.
Yeah, mine is in Silicon Valley.
No, is there something structurally wrong with their architecture in terms of on how they're pushing the problem, or is it just too early? Like, is it just not enough work being done? Like, it's one thing to be too early, and it's another to be the wrong.
Well, they're
solution.
doing what I think, right? Anybody in their shoes would probably be doing the same thing. Because the next logical question was the one we had up there last. Where do I go with this? So the next logical thing is we need to create orchestration. So they're trying to control it, right? Just like when Sun was around running Java, you had Oracle really pushing hard on the JCP. It happens everywhere, right? They want to have influence over it, but there's a great, I can find it if you want it, there's a great rant that Solomon had in July against a Googler. And the Googler has more patience than any human I've ever seen, because he's like, can we just all get along? And he's just hammering, and it was because, and Solomon's just pissed off that Google was breaking the APIs, because this is, so there's some emotion, of course, involved, and there's some people with some strong opinions involved. It's going to be interesting to see how it goes down. Where I personally see a lot of value right now in this ecosystem, and I'm anxious to see it completed, is in libcontainer. So if the three things talked about at DockerCon, you have libcontainer, you have Docker, of course, on top of that, and then you have libswarm. I'm not a believer in libswarm, and you're going to have, the only way that different infrastructures are going to show off their own stuff is to differentiate. So you're not going to get everybody to conform to some orchestration. It's just not going to happen. I'm not a believer in that. But the libcontainer thing's going to happen, I believe, and I think it's in current rewrite, and as soon as that's in place, I think good things are going to happen. Because for us, with Mesos, we actually drive things through, we fork off and drive through Docker. As soon as we can, we're going to move to libcontainer. So, yeah, cool stuff. All right, where am I at? I'm completely lost. Oh yeah, the directions of things, right? I got distracted. The direction of things is moving away from the monorail into microservices. It's almost like buzzword bingo over Java 1 this week. I think if you put multiple places on your chart for bingo microservices, you'd be winning right now because everybody's talking about it. I'm scared of this a little bit. And the reason why I'm scared of it is 10 years ago, maybe 15 years ago, we were doing exactly the same thing, except we called it SOA. And in that SOA space, we didn't do so great. And my personal assessment is that it's not well understood the granularity of services. That's usually the problem. I see people just throwing any kind of object they want on the bus or publicly exposed. And we're not so great with encapsulation. So understanding that, I think, will get you a long way. But it is happening. Microservices definitely happening. If we were to have some goals, what would they be? If we were to start completely over this whole new cloud solution, what would we do? Hit the reset button. Some of this is subjective, right? The first one would be lightweight. That's subjective. But the difference is 2 GB images versus a container. Multi-seconds to start up versus milliseconds to start up. That is measurable things. You run into consequences like you brought up on security. We don't have great answers in the container space yet. So, metadata. You got to be able to ask the container what changed. You got to talk to the thing and have metadata around it. It's a big deal. If you want automation, we have to be there. We want total elasticity, meaning we want to be able to bend pack services onto the same node. In order to do that, we can't know where the thing lands. We don't know at all. We want to be able to not remove pages, but reduce it. I can give you an example of Airbnb. They have 2 very similar size of clusters. One is their analytics, which is completely based on Mesos. The other is their web services. They have less than 1 admin or ops person on their analytics cluster, and they have 8 on their web services. So I don't know if they're completely comparable, but it's interesting to look at the analogy. We can start to reduce the amount of operations when we start moving to a common model like we have with Mesos. The other that we want to do as far as goals is to remove snowflakes. Snowflakes are evil. The common thing that I see today when I go to clients is they have somewhere in the neighborhood of 400 chef recipes for their data center. If they were to re-provision between the buildup of different models that they have, or the buildup of recipes, all the way out to everything they need in their data center. It's usually around 400. It's in the multi-hundreds. We would like to build complete conformity across the data center. So what you need for a recipe is the master, and you need a slave. Now, do I believe this is 100% true? No, I don't believe that. When I look at one of our largest future clients, I hope they become one. They're a big financial firm. They have 3 different types of machines, and those machines really are geared up for specific things. So they have SSDs on some nodes, they have JBOD on another set of nodes, they got RAID on another set of nodes for different purposes, right? So there are reasons to have specialized hardware that will probably not change, but in general, we want to reduce the snowflakes. We just want to have a few, and we want to create, most of our services can just go anywhere in the cluster. That's not true with several, right? And one of the problems we have today is, of course, I think most architects realize, most developers realize that you want to work as close to the data as possible. So there's this, hey, these 2 things should go close together. We want to reduce the latency of these things. But there's the other direction as well, right? You cannot put a Kafka service and an Accumulo service on the same node. That would be a really bad idea. They both have impact to the OS cache, the page cache. They're just thrashing page. So it's useful to know that there are things that oppose each other, and you want to make sure that they land on different nodes. The other thing that you would want, it doesn't exist today, we're trying to build this out in the next quarter. Today we have just standard offers when we talk about a scheduler. Where we're going is that we're going to have something called persistent offers. It's in the public workspace, so if you're looking through our code base, you're already seeing it. But the idea of a persistent offer is this. If you have Kafka go down, ideally, if possible, you would want it to start back up on the same node. And there's chances where that might not happen, but if you can, you want it to. So we want to be able to deal with that situation. We also will have resendable offers. And the whole idea with resendable offers, which I absolutely love, is we started stealing a term from Google. It's their term. It's not really critical. It's not a trademark term. It's a tier 0 and a tier 1 service. And a tier 1 is a guaranteed reservation of resources. So if you have your web service, let's say, and you want to say that it requires half of the cluster, the likelihood is that given different parts of time, it may not consume the whole half. It might only be using a quarter. You have other services which would be tier 1, and they get best of service. And the idea is it can steal resources that would have been reserved for tier 0, knowing that it could have that offer rescinded if the scale increases where tier 0 starts to scale up to demand. Does that make sense? So that should come out in the next quarter. Actually, should come out in the next month. So and that leads me right into this slide, which is we want the ability. Again, this is goals, right? We want the ability to, at peak time, focus on web traffic and do the rest with analytics. And on off-peak time, we want to be able to ramp up and use the utility of the resources for analytics, even though web traffic is low. That's the focus. We'll gain a lot of utility out of our data centers. Another goal, of course, would be process isolation and then to stop shaking yaks. Usually the story there, but I'm not going to go through it. All right, I'm going to assume that there's at least some people here that are not familiar with Mesos as a whole, so I'm going to go through that real quick. Our technology stack is this. By the way, everything that we have today is in the open source space, so we don't really even have a product yet. We will be working on a product that doesn't exist yet. It's an idea. So our stack looks like this. It's Mesos, Marathon, Kronos, HA proxy. We do have Docker support. Probably add a few more things in there, but that's the core of it. That's what we deal with every day. What is Mesos? Well, first of all, it's an Apache project. It's scalable. It scales out nodes, provides fault tolerance. It provides all your networking communications as well. In fact, Florian says that in building out Kronos, when he compares it to something, and I forget the project he was comparing it to, he's comparing it to a project that's similar in nature and it's distributed. He's guessing that he did not write 50,000 lines of code that would have been required for networking because it's all just using Mesos. So one style application you could write is just a distributed application that leverages Mesos as a distributed way of aggregating resources. And I can give you a story around that a little bit later. So our goal here is to take your whole data center, which is a number of nodes, and to make it look like one machine. That's our goal. So, and we're not worried about bare metal or virtual machines. In fact, you can have a combination and we don't care. That's the cool part. You can figure out whatever's best in your data center and we'll just work that way. We clearly are working with people on EC2 and on Google Cloud Platform. And we're working on a bare metal data center. So the idea and concept is super simple. We're going to aggregate the memory, disk, CPU, and just like in a biological system, you could get down to looking at cells, which are clearly important. It's really the whole aggregate of it that we consider the organism. So we consider the data center, the organism. And we actually consider Mesos to be a distributed operating system. Right? And in fact, if you look at Wikipedia and you look at what the definition of an operating system, and you take out computer and you put data center, we do exactly that. That's what we do. So it's an interesting analogy. An interesting phrase by Ben at MesosCon last month. This last decade has been looking at the data center, which is a cluster of nodes. It's his belief that in the next decade, we'll be looking at clusters of data centers, which I find fascinating. And guess what question I keep getting now? That very common question. It's more advanced, so I don't get it all the time, but it's what can I do across region, across zone? Okay, well, I don't have an answer yet. Right now, we manage each data center with essentially one master, or one set of masters for a given data center. Going across is not something we have an answer for yet. But again, that's the next decade of stuff that we're going to be working on, I assume. Yeah, a quote by Ben. I'm not going to stick on that. So what is Mesos? The core of it is this. We have a master, we have a slave. The slave is responsible for execution of tasks and for isolation. And then you have something that drives that. And that's at least the terminology. I think I have a better slide that builds in the analogies a little bit better. If you were going to look at it from a topology standpoint, this is what it would look like. In an HA mode, you'd have a quorum of zookeepers, which all are being leveraged by a quorum of Mesos masters. If we use zookeeper for leader election, only one of the masters would be leader at that point. And then we have any number of slaves, whatever number you want. And I realize some people are offended by the term slave, but there's been conversations about getting rid of that term, but it's going to stick. I don't know how to get rid of that. Right? So that's what we refer to. And essentially, it's an agent that's going to be on every node that's going to provide resources. You can see here I have Hadoop scheduler that is talking with the master, and I have a Hadoop executor. Whenever you're going to create a framework, typically you create those two components. Something that's going to schedule things. When it's notified that something was finished, when it was notified something was failed, it's the thing that decides what to do next. Right? Here's another look at the topology. When a framework registers with the master, it doesn't actually ask for resources. Once the master knows that there's a framework that's interested and offers, asynchronously, the master will then offer that up. Hey, I've got some services. Do you want them? So there is a resource offer that is made. When a scheduler wants to launch, it will tell the master to launch it. It will find a slave to launch it on, and then we'll have an executor on that slave launch off the tasks themselves. So, like the OS kernel, yeah, quote, quote, quote. There's a nice diagram here that I'd like to go through, and then I'll show you a demo and get off the stage. The first is that whenever we're dealing with Linux, hopefully we all realize that there's an init or an upstart. There's something that manages the run time, right? The running of a given application. And it's very rare that you actually program against the Linux kernel itself, unless you're building a driver. So that's the level of abstraction that we tend to work with. And if you look at the distributed world, that's how we see Mesos. Mesos is the kernel of the data center. Marathon is the init process. It's the init system. And even when we use Kronos as a different type of framework, we launch it through Marathon. Marathon is our init system. So Marathon is the thing that we also start up in HA mode to make sure that it's highly available. And here's what the full topology can look like, or tends to look like. The number of servers that are being managed by Mesos with Marathon and Kronos. And then you could build your own framework. Real quickly before I show a demo, why might you want to create your own framework? Well, again, a client I can't name, but they're in the hedge fund industry. Super cool stuff. What they decided that they wanted was when a given agent creates an algorithm, if that algorithm makes more money than any other algorithm, that person gets more priority in the cluster for the next runs. So completely monetary driven, right, weighting of algorithms being thrown into the cluster. It's pretty interesting stuff. So let's look at this real quick. There's one major thing I want to show you. I started up a Vagrant instance that has a master and a slave in it. So I'm looking at a virtual machine and VirtualBox running a Mesos cluster, but it's really just one slave, right? Once you start it up, I can see that there's Marathon running, and I have one instance of sleep going on. It's exciting stuff, right? I have an instance of sleep. In fact, actually, when we scaling it up is nothing more than clicking and saying, hey, I want more of those things. So hopefully those will spin up more sleep. Actually, there we go. It's a bit weird. I'm not on the latest version, so. I wanted to show you a couple things I think are really fascinating. I'm obviously not launching Dockers. I can show you how to launch Dockers. I can manage what's going on with the number of tasks. I can see what the configuration of this thing is. I can look at it from a RESTful API. I can look at the number of apps. The whole idea is that you can orchestrate this thing on your own. Like, we don't do it, but it'd be really simple to monitor HA proxy to see the number of requests have increased from 3 requests per second to 10 requests per second, and to tell Marathon to launch an extra instance and auto scale up. Right? You could easily do that through just the RESTful API. So that's the general tour of Marathon. All of our products have the ability to say Slant Help on them. You get full documentation around what the RESTful APIs look like, as well as saying this GET request, here's what could be expected from JSON. So good documentation throughout, right within the product as opposed to external. So that's useful. So what I want to do is answer that question that we were talking about earlier. If something lands somewhere and you have no idea where it went, what do you do about that? Well, first of all, here's Mesos, the master. I can see the number of frameworks attached. This one here is Marathon, the one we're looking at. It is currently managing and monitoring these 3 active tasks. When a task was launched, it belongs to a given sandbox, and in the sandbox you have a standard out and standard error, and that's all we're doing here. It's a very simple thing, right? I'm not running a Tomcat instance or a Rails app or anything like that. Let's go out to, I'm in the sandbox. I am now going to show off a couple of tools that we just newly came out with that people are just not familiar with yet. I'm going to say Mesos PS. I can get a list of things that are running in the cluster. I can do this remotely. I can just point to a Mesos master that's somewhere in the cloud if I wanted to. So this is giving me a list of instances of things running. In this case, I only have 2. I have Ubuntu. Yeah.
Is this released?
This is released, yeah.
So it's 0.20.
You know what? It's not included in the core yet. We are going to integrate it into the core. We have commitment from the core team that they are going to do that. But it's just the Mesos CLI. So you'll find it off of our repo. And it's, I think you can use pip to install. So pip Mesos CLI. So that's pretty cool. Also, it has autocomplete. I could say tail, tab. Oh, that's not a bad example. Let's go sleep. Well, that didn't work very well, did it? Oh, it's Ubuntu. So I just said tail, and I didn't complete it at all. I just said UB. I have a tail of standard out of all the tasks that are currently running out there, right? I could also follow that, by the way. I could be very specific. I can say, I don't know why my autocomplete's not working, but instead of hunting that down right now, I could just say Mesos tail this thing, and so now I'm just getting the 1. I could say Mesos, I don't want standard out, I want standard error, and so now I'm looking at the standard error instead of standard out. But I could also do this, and this gets pretty cool. I could say Mesos SSH to that node. I have no idea where it's at in the cluster. I just know that it failed in this particular case. I'm not sure why. The demo gods are pissed off at me. If I were to guess, by the way, there's a challenge whenever I'm shutting my box down and I still have Vagrant up, and it's a virtual machine challenge. So, but I've been doing this demo for some time, and usually it would launch me right into the sandbox. So we'd be staring right at the sandbox with a Unix or a Linux prompt. So the remote host identification has changed. It's scary stuff. So
You probably left your VM IP the same, but the actual key changed. So.
yeah, that's what I'm guessing as well. Something along those lines. So since we were talking about Docker, why don't we go into the demo here and show off a couple things. The first is, let's just do Docker. If I wanted to launch a Docker instance, it would be nothing more than saying launch this guy right here. So here I'm going to be doing a sleep within the Docker image. I already have it local. There is a check that happens. We always verify through a pull. So that's something that people are asking for, is let's not do that. But the reality is that's probably what you want. We can use private Docker repos, but it would require, of course, you passing around your Docker config file, which has your credentials in a base64 format, which is not brilliant, but is what the state of things. So if I just said launch, simple Docker, yeah, so I've got issues. All right, so I'll let that go for right now. Also, worth checking out if you're interested is this. If you go out to google.mesosphere.io, We just provided a service that will provision Google Cloud Computing for you. And there's no fee associated with that. There's no additional charges. You will have to have a billable account. So, but it's worth checking out. It's a super simple thing. Just jump in here, make a selection of what cluster size you want. You can pick for development mode or high availability mode. You can see the instance differences. So, with that, I'll turn the time over. Yeah. Any questions? Thoughts? Yes.
How does Mesos compare to Yarn?
See, I already pissed off the Docker folks, and I pissed off the Kubernetes folks, and now you want to bring one more in, right? So a couple of things. We had one of the Yarn guys come in for a hack week, and they're looking to put Yarn on top of Mesos, which is an interesting thought. Yeah. I realize that Yarn itself is a scheduler. Yeah, another one. Here's the deal that I think is worth evaluating. First of all, I don't know of any Yarn clusters bigger than a few hundred that don't fall down beyond several hundred. And I can give you resources to contact and talk to if you need them, because I don't actually know them personally. It's this third party for me. The second thing you run into is whenever you're doing some Hadoop-like things, when you want to bring on a second version, a new version, you can't actually share the same clusters. You end up provisioning a whole new environment, and you want to do analytical comparisons to verify that things are still as they should be with the new version, and then you will probably repurpose the previous version. Within Mesos, we can actually run two different versions of Hadoop at the same time in the same cluster. So there's some pretty cool things I think we're adding value in. Yes?
What is the next thing for Mesosphere? Now Marathon works more or less. What is the next that the company will do?
Yeah, on our roadmap, I think I identified several things, but I can tell you kind of where our product will be going, and maybe that will help. The thing I'm most interested in, but I don't know, I'm talking like 6 months out now, maybe a year out. Humans, developers are terrible at capacity planning. You ask a Java guy how much they need for their Tomcat instance, they'll say a half a gig. And if you say, what's the worst case? And they'll go immediately to a gig, and you have no justification for any of this, right? So we are going to build we're going to build on top of Mesos the ability to do machine learning and understand what is really being utilized by your application. The first version of that will probably give you recommendations. Hey, we're seeing that you need less of this. And, the second thing that we'll do is probably automate it. Probably automate the re-provisioning of a given application based on new heuristics. So,
And is it something that will be open source, or?
That won't be. Probably. I doubt that will be. I doubt that will be. We'll probably also build on some monitoring tools to be able to look at the data center as one big picture. So you can almost look at it like a gas gauge, right? You can go, oh, I need another node. So you just throw another node on and gas gets filled. So there's probably some other additional things we'll do there. Well, I imagine that we'll learn from the Kubernetes as well. And with Deis, and I could give you a number of examples, but we'll probably add in tagging, we'll probably add in, well, maybe we'll just implement the Kubernetes thing. I'm not exactly sure, but we'll probably leverage some of that knowledge. So. Oh, yeah. Oh, see how he stuck around that?
So one is that you said across the data center, the next thing is to manage how to execute and we have comment on OpenShift in that place. And the second question is, you talked about networking, alluding to problems stuff. Do you complete what you want to say, or do you have any comment on the next line in the context?
Yeah, I just got to, I don't know how to answer your first question was around OpenShift. I don't know enough to really say something. I will say this, though, on the networking side. Things are not great, you know. You have two different options with Docker. One option is you use host mode. In host mode, whatever port you have is bound at the host NIC, which has the advantage of being able to be advertised throughout the cluster and do a service lookup right on that. The other mode would be bridge mode. And in bridge mode, you essentially have it's like having a WAN system where I'm added into this space, right? And I have Docker managing this IP, which I cannot advertise. So I need to figure out how to bridge across. So with using Docker containers particularly, I think we're going to we're in our infancy, and I think we have to solve that problem. We need something where I can advertise a Docker service on a node to the cluster and have it discovered. And that doesn't really exist right now.
A couple of solutions, like we ran some OBS, GX solutions there, are trying to address the problem. So do you have an idea how Mesosphere would help?
Actually, I do have an idea. I don't know if I'm supposed to talk about it.
Okay.
I do have an idea of what we're probably going to do. The short of it will probably be everything we do with Mesos essentially is the aggregation of things. We don't have anything that's cluster oriented, but this probably changes. You will probably have to hand off a subnet of IPs to be managed as a resource. And the other problem you have is service discovery, right? And the approach I see that is the most common one that consistently works is having known ports that are dedicated to a given service, and then having something that manages the number of tasks behind that. So, and you can look at a number of examples. SmartStack with Airbnb is a good example. There's a number of them that are like that. Whether you have a HA proxy per node or an HA or not per node, but as a known IP address, I think is irrelevant. HA proxy is pretty good tool for that kind of thing. Cool. Yep. Thanks.
Thanks, Ken, again for sharing again your thoughts on the future of development. Right now, we have a short talk by Colleen, who's on the one of the engineering teams at Coursera, on how we're using Mesos and Docker internally. So, with Colleen the setup, we can get started on that.
Hi, I'm Colleen, and I'm a software engineer at Coursera. So today I'm going to be talking about Iguazu, which is a project we've built internally using Mesos and Docker as our solution to, when we need to run long-running jobs, how we deal with that. So to understand the context for this, let's take a trip back to 2011. This was actually in the pre-Coursera days. So Coursera didn't exist at the time as a company. It was more of a research project where we were experimenting with putting MOOCs online. Massive open online courses. So at the time, we had our online serving stack. We were serving, like lecture videos and quizzes to students. But not everything can be run as an online service. So we started working on an offline job running service. And this is the sort of the first initial commit in that. And like the one line here is basically, this is the job running platform for things like the SQL autograder, etc. We want to split this to keep whatever is in our main web servers clean and tidy. So essentially, the SQL autograder is a good example of something we don't want to co-locate with our online service. So for one of our classes, a database class, we had homework assignments that would ask users to submit sort of like SQL queries, and we would basically simulate running this SQL query. And as you can imagine, running a lot of these would be very sort of CPU intensive, and so as a result, we didn't want this to decrease site performance while these queries are running. So as it turns out, the SQL autograder itself was maintained as an online service, so we just moved it onto a different box. But there was plenty of other work for batch jobs. Among these were things like gradebook exports or class-wide regrades of quizzes, lengthy video recoding processes, and sending, say, emails to an entire class of students. Okay, so we have plenty of work for this system. And as you know, a perennial problem in the field of software engineering is coming up with a name for projects. But in this case, we envisioned a stream of jobs flowing through or cascading through a system. So thus, Cascade was born. All right, so let's talk about the life cycle of a job in Cascade. Just run through the system and see how it works. So I guess for context, first of all, remember that this is something way back when we were sort of under severe time constraints. So this is sort of like our simple first pass at the system. So our story starts with the client. Most jobs are initiated when an instructor or admin goes through the web UI on our site and says I want this class's gradebook exported or something. And so in this case, the client is going to be our web front end. So what the client does is that it uploads job data to SQS, which is Amazon's simple queue service. And I'm not going to go into the details of how SQS works here, but the reason why we chose it was that, first of all, we were already using Amazon's like EC2 and other systems, so it integrated nicely. And secondly, when time constrained, you want to look for external services that you don't have to maintain, you don't have to run yourself. So this was the most convenient way for us to queue these offline jobs before they can be run. Then we have Cascade. So Cascade consists of a few machines, each of which are running a few workers. And what each of these workers do is continuously pull SQS for new jobs. When they get a new job, they'll dequeue it and they'll start running the job. During the job running, it will send status information to the database. And then when the job is complete, and when the job is complete, the worker will pull SQS again. If there's another job, it'll run it as before. If there are no more jobs, it'll sleep for a while. After all this, the client can query the database for the job status, and then if the job is done, it can report to the user that the job is complete. Okay, so this is sort of like a basic first pass. Seems like a pretty reasonable thing. But there's a reason why I'm giving this talk, is that there are actually a lot of problems with this. So the first major problem is that we don't really have isolation here. So on each machine, we have several workers running, all competing for shared resources. If this resource is CPU, since each of the workers is single-threaded, it might not be so bad. We could sort of lock each worker to one CPU, and then they don't really compete in that sense. But if it's memory, we might have more serious problems. So in this case, if you imagine that worker 2 just starts using more and more memory, worker 1, what can actually happen is that worker 2 dies. And this is not great for debugging, because worker 2 in this case did absolutely nothing wrong, yet was the one who suffered the consequences. And another thing this means is that it actually limits the kinds of jobs we can run. So far I've been talking about jobs that we write, jobs that are sort of trusted, so to speak. But if we were to do things like, say, grade student-submitted programming assignments, we would essentially be running some code that we don't really have fixed parameters for, like how much memory they use. And without isolation, we can't safely do this on this cluster. Another issue is that the deployment flow for Cascade is fairly fragile. So here I want to make the distinction between system code and job code. So in an ideal system code is updated rarely. So ideally, you build out a system, maybe you debug it a little bit, but then you basically stick it in maintenance mode. Job code, on the other hand, if you've built a good system, is updated very frequently. So if you've built a good system, then lots of people will be using it, and then lots of people will be writing new jobs, and so job code will be updated all the time. And this was a distinction that we sort of realized. We stuck them in different repositories, but because of the way our workers ran, this dependency came back to bite us. So one other thing I want to mention is that within Coursera, Cascade is sort of like a unique system in how it runs. As we've developed our best software engineering practices, we have a fairly good, or at least for a startup, a fairly good deployment story around, say, like our front ends or our Scala service backends. But because Cascade is sort of a unique snowflake in a way, we don't have specialized deploy tooling for that. So remember when I talk about deployment that this is a fairly manual process. So remember that in Cascade, the worker threads continuously pull for new jobs and run these jobs. So what this means is that, first of all, the job code is run sort of like in process, which means that because our worker threads are written in PHP, the job must also all be written in PHP. So this is not great. The other thing that it means is that if we wanted to update the job code, we would first have to terminate its worker, update the code, and then restart the worker and be in our merry way, running the new code. So this might seem fine if you're just updating a worker, if you're just updating, say, like the worker code, then it makes sense to just stop the worker and not have to hot swap the code. But remember that this is job code. And so this is something that's going to be updated much more often, which means that you don't want to have to, say, kill like unrelated jobs in order to update a completely different job. Also remember that Cascade is several machines, each running several threads, and each of these machines needs to be updated. Each of the threads needs to be restarted. So as a developer, if you want to just go in and say, I want to push the new code, I want to test my changes, let me just go restart everything. That's actually not so easy, because then all the worker threads need to be stopped. What that means is that you either need to wait up to a couple hours for the current jobs to finish running, or you need to just like stop them right away and terminate some poor instructor's grading job and then he'll wonder what happened to it. The last point I want to make is that when we were building this system, at the time, including for our online site as well, basically everything was in production. So we didn't really think about the developer story very carefully, and so this was something that sort of came out as a result. So this is the diagram I showed earlier. This is like how the flow of the code works in production. And so for dev, we try to emulate as much of this as possible. And so we emulate, the clients, the front-end code, the Cascade, and the database store. One thing we don't emulate is SQS. And the reason for this is, first of all, part of the reason why we didn't build our own queuing system in the first place is that we didn't want to have to put in that work. And so it would have been a waste to have to build that for the dev environment anyways. The other thing is that, as you can see, SQS hooks into multiple places. It hooks directly into the client, it hooks directly into Cascade. And so we would have had to change those connects directly to use our own version of SQS. So that means that we have multiple dev environments, all talking to Cascade. And since we didn't want to create Cascade or SQS queues on the fly, they actually talk to the same SQS queue, which leads to strange situations, such as one dev uploading a job to the queue and another dev pulling it down. In such a case, he might not even have the code for a new job someone is developing, and so his client will crash because they have no idea what this job is. So we've talked about Cascade, and it has some issues. One other issue I'd just like to point out is that we're essentially tied to one language because of the way our workers are designed and running things in process. So we have a Cascade, and we could write Cascade Scala or Cascade Python. But this is not great because, first of all, it duplicates work, and secondly, it runs into the issue of static partitioning that Ken mentioned earlier. All right, so what can we do? So fast forward to this year, where we were thinking about what we can do about Cascade, maybe write a Cascade v2. And so we want to solve all the things. We want to solve all the problems I've mentioned. We also want to do a little bit more. So ideally, we want this new system to be responsible for running all offline jobs. So basically, we don't want to co-locate any offline jobs with online jobs because of load considerations. So that includes things such as, database migrations, scheduled jobs in general, and things like grading student-submitted programming assignments. And such, because we were expanding the scope of this project, we didn't think it was appropriate to call it Cascade v2 because it was actually a very different beast. So we called it Iguazu. And so the reason for this is that the natural way to name the successor to a system called Cascade is to name it after a famous waterfall. And why name it after Niagara, which is a system of 3 falls, when you can name it after a system of 275? So now I'm going to talk about Mesos and Docker, which are 2 of the tools that we used in building Iguazu. So you've already gotten a quick overview of these, but I'm just going to highlight some of the important points for us. So for Mesos, basically we get resource isolation for free because it uses C groups. In case you're not familiar with C groups, they stand for control groups, and they're a Linux kernel feature based around isolating and monitoring the usage of various resources, such as CPU and memory, and also things like disk I/O. In addition, in Mesos, the masters have soft state. So this means 2 things. One, they have state, which means that they provide a bird's eye view of the cluster. They can tell you at all times what the status is of all jobs on that cluster, whether they're still running or not, whether or not jobs have finished. But it's soft, so this master is not a single point of failure. And as it turns out, you can actually run multiple masters on the cluster to maintain these properties. The last point is that in terms of implementation, Mesos does a lot for us, but it leaves the nice juicy parts up to us to implement. So in this case, that's the scheduler and the executor. So the scheduler is basically responsible for managing the whole resource offer, managing the resources, accepting and managing the resources, while the executor is basically responsible for running the task. So the other main tool that we used was Docker. And so you can think, in case you're not familiar with Docker, it sounded like a lot of you were, but you can think of Docker sort of like a lightweight tool that provides the abstraction of a VM. So for us, it was a very nice packaging solution when we were moving from Cascade to our new system. So one thing if you've worked with Docker, then you'll know about Docker files. And so one way to build a Docker image is to write a Docker file, which is like a sequence of commands, and then basically just build with that file, build this image. So these are the first few lines from the Docker file we used for building Cascade. As you can see, it has things like the base image, maintainer information, and also the sequence of commands used to set up the image. So this is actually nice because one thing we found with our old Cascade machines that we had, over time, accumulated all sorts of dependencies, and we had no idea what we had installed in that machine. So in this way, you can go back and look at the Docker file and sort of see what's installed, see what you need. These are a few lines from the end of our Docker file, and it contains things like, say, user, because previously you were installing all these dependencies, so you needed like admin access and sudo, but maybe you don't want your job itself to run with sudo permissions. So it has that. It also has the ability to set the working directory for when the command runs, and also the home environment. Another nice thing about Docker is that it's, oops, backwards. Another nice thing about Docker is that it's convenient to set up private Docker registries. And so what this means is that our deploy process is basically you bake a new image and then you upload it to the Docker registry. And then when the job runs, it will pull down this updated image. The other good thing about having this registry is that you get versioning. So if you remember earlier, in this base image, it's named Ubuntu:12.04. The 12.04 here is a tag, so we can essentially tag all of our images and use that for versioning. And that's very useful when you're going back and trying to debug why something didn't work. Okay. And the last point is basically to run Docker, you just specify the image and you specify the command you want to run on the image. So let's talk about the life cycle of a job on Iguazu now. So as before, we start with the client. Then, instead of submitting the job data directly to SQS, we go through Iguazu. This is just a nice abstraction because when we want to run on dev, we can then replace the SQS with an in-memory queue and avoid the dependency we mentioned earlier. This is, of course, something we could have done if we were thinking carefully about it from the start, but this is something we're fixing with our new system. Then, Iguazu has a job manager that runs and pulls SQS for new jobs. This is sort of similar to the way the Cascade workers worked, but the difference is that the job manager is not itself responsible for running the jobs. So that means that we can keep it lightweight, and it can actually continue serving online requests about the status of jobs on the system. When the manager finds a new job to run, it will start up a scheduler. And what the scheduler does is, it fits into the Mesos framework. So it basically will register with the Mesos master. And then it will go through the whole offer process, select one to use, and then it will tell the master, I want to use this offer, and you should start up an executor on the slate. Since we use Docker in our workflow, the first thing this executor does is to talk to the Docker registry, check for a new image, and if there's a new image, it'll pull it down. Then it will run the job, and this basically works the same way as before. Then when all this is done, the master will report that the task is finished. The scheduler will then trigger a callback to the manager, and the manager will be able to update its state about whether or not the job is running. And then in the end, as before, the client can report to the user that the job is finished or what the status of the job is. So let's revisit the promises cascade and see what happens with Iguazu. So Iguazu uses Mesos. Mesos uses cgroups, so we get isolation. Check. In terms of deployment flow, we now have this private Docker repo. So now we have a clean separation between system code, which is basically Mesos code and Iguazu code, and the job code, which is encapsulated inside the Docker images. Then we also have an improved developer story now that we've had the proper abstractions. You might wonder that we've added some new dependencies since we're using Mesos and Docker. Fortunately, in terms of Mesos, we run on our virtual machines that we use for dev. We run Ubuntu, which is the same as the slaves, so we can just abstract that out and run the job directly. In terms of Docker, if you set up your images correctly, meaning if you don't load your config inside the image, but instead map it in at runtime, then you can actually use the same Docker images you use in production as on development. And last but not least, we're not tied to one language. I just want to highlight a couple of other benefits we gain from this system. So for one, we had a fairly easy transition. So for Mesos, they just handled the job running piece. And for Docker, we could basically take Cascade, package it into a Docker image, and use it as is with Iguazu. In addition to that, performance, so while testing, we actually run Cascade in parallel with Iguazu because our jobs are supposed to be idempotent, so it's fine if they both run. And what we found is that Iguazu actually runs these jobs faster. And there are a couple reasons we can come up with for this. One is that Mesos is designed to be long running, and Docker, by virtue of just having an image and starting it up afresh every time, doesn't accumulate any state that makes it bloated and slow. With PHP, on the other hand, it isn't really designed to be long running, so our worker threads would actually just get more and more bloated, and eventually we would just have to restart them periodically because they would just get really slow or hang. Then we gain flexibility. With the usage of Docker, we already have like a wide range of jobs that we can run. And you can imagine that if we think, we don't really need, to simulate a file system in order to run this job, we just want to do some simple task, we can write more specific executors for things like Scala jobs, since Scala is popular in this company, or for other languages. Then, so one nice thing about Mesos is that it gives you very fine-grained control over scheduling. And one cool thing that we can do with this is auto-scale our cluster. So if you remember that Iguazu has a bird's eye view over the jobs in the cluster, it can determine, the cluster is under heavy load. And so, let me spin up more, let me go through the Amazon AWS API, spin up more Mesos slaves, and have these automatically register with the master. Then, so we have an appropriate load, and then when load is too low for the cluster, when the cluster is over-provisioned, then we can automatically scale down the cluster. But when we do that, we can first start scheduling jobs selectively, avoiding certain machines. And then when the jobs on those machines complete, we can scale down those machines when they're not being used. So that way we can auto-scale up and down without affecting any running jobs. The last point is that Mesos is designed to work on a heterogeneous pool of resources. In the most basic form of heterogeneity, we have machines of different sizes, for example, and Mesos will automatically pick up on this. In a more sort of advanced form of heterogeneity, different machines may have different permissions. So on Amazon, permissions are generally configured through things called security groups. And what this means is that maybe, I'll be in a security group that allows me to access this database that may contain sensitive information. So if you think about the jobs that we want to run, we have both internal, say like gradebook jobs, and we also have sort of untrusted, say like student code jobs. So we can schedule selectively, we can schedule our own jobs on machines that have access to our database, and student submitted code jobs that don't have access and are basically heavily isolated. All right, so thanks for listening to this. I hope you found this helpful, or at least interesting, and we are hiring, so thanks. Any questions?
So how did you solve your initial problem where a job might have been submitted to the queue and is expecting a different version of your code to run?
So that particular problem was specifically for the dev environment, where we had a shared queue among developers. So you'd imagine that, say I'm working on a new kind of job, so I submit this new kind of job to the queue, but then you pull it down, and so you get this, and you have no idea what this job is because I haven't pushed it to production yet, right? So this is sort of like a dev-specific issue, where in this case we're using an in-memory queue instead of SQS, and that means that there's no chance of me pushing and you getting the job in development.
Although fundamentally that problem could run in production. I mean, you could run in that problem in production if the jobs are just queued up for quite some time.
So this would be, okay, so this would actually be a matter of...
To production, so you shut down production, you have a bunch of queues, jobs in the queue, you update your production code, fire it back up, it starts reading the queue, and then the code might not do what you want.
So this is, I guess this is talking about, instead of a new job, this is talking about an old job that no longer exists.
talking about existing jobs in queue in production that expect the old code instead of the code that you update. So you could only do a production upgrade when you make sure the queue is clean.
So you don't necessarily have to make sure the queue is empty. I would just say that it's probably good practice in general to not update your jobs in a not backwards compatible way, such that if you had like an old job, like if it's like fundamentally different in such a way, you might just want to call it a new job instead, rather than have it be interpreted differently depending on which version of the code is running.
What are you using for the executor? Are you using Demos? Or?
So when we built this, we were actually on, I think, Docker, or sorry, Mesos like 0.18.0, at which time it wasn't out yet. So we've looked a little bit at the Docker, the sort of executor that comes built in with 0.20. And it does a lot of similar things, actually. Like our config story where you don't want to keep config on the image and actually want to map it in, it does that. It provides a way of doing that by generically mapping in files. And also just things like using the host network configuration, we're doing the same thing. So that's encouraging. We'll have to investigate further on whether we actually want to switch, because there are certain things we do customized for our environment that might give us more value. But yeah.
Okay, let's thank Colleen again. So thanks everyone for coming. So Ken and Colleen will be around for more questions. If you're interested in talking to Coursera folks, they're all in that corner for some reason. Yeah. And so there'll be more talks coming. I think next month we have a talk on Android development and more to come. So hopefully to see you guys again soon. So thanks a lot.